In this lecture, we are going to study the t distribution. Sampling distribution on the assumption that they are normal or approximately normal or valid when the sample size n is large. For small samples like n less than or equals to 30, we consider the t distribution. Let n be the sample size, x bar be the mean of the sample, mu be the mean of the population, and S be the standard deviation of the sample. Then consider the statistic t defined by t equals x minus mu divided by S divided by root n. Suppose we obtain a frequency distribution of t by computing the value of t for each of a set of samples of size n drawn from a normal or a nearly normal population. The sampling distribution so obtained is called the student's t distribution. Or just t distribution. The curve represented by the function y of t equals y naught times 1 plus t square over n minus 1 to the power of minus n over 2, where y naught is a constant for the t curve. The constant y naught is generally chosen in such a way that the total area under the curve is equal to 1. For large values of n, this function y of t reduces to the standard normal distribution density function, which is given as xi of t equals to 1 over root 2 pi e to the power of minus t square over 2. And the t curve becomes the standard normal curve. So here we can see the comparison between the t curve and the normal distribution curve. The blue one is the normal distribution curve, and the green one is the t distribution with 1 degrees of freedom. And here I will be showing the simulation wherein as we increase the degrees of freedom, the t curve is going to coincide with the normal distribution curve. So you can see how the degrees of freedom is changing in this legend on the top right corner. So now 36, 8, 40, 43 up to 50. So here again it goes from degree of freedom 1 to 50. You see on how the green line coincides, the green curve coincides with the blue curve. Okay, so setting gamma equals to n minus 1. So our curve y of t can be written as y of t equals to y naught times 1 plus t square over gamma to the power of minus gamma plus 1 over 2. So this quantity gamma equals to n minus 1 is called the number of degrees of freedom for the statistic t. Okay. So for population means the confidence limits can be obtained, and it is given as so these are the confident limits for the population mean, and you can expect that the population mean would belongs to this interval x bar plus or minus tc into s divided by root n, where this plus or minus tc is called the critical value or the confident coefficients whose value will depend on the level of significance and the as well as the degrees of freedom or the sample size. So for a specific gamma, T beta of gamma is the value of Tc at beta equals to alpha percent level of significance, and of course gamma is the degrees of freedom. And generally we will be considering the alpha percent, either it is 95% or 99% level of significance, or it is beta is 0.05 or 0.01 level of significance. At the beta level of significance, the confidence interval for the t-score, so this is the confidence interval for the population mean. So here the confidence interval for the t-score, the statistic t, is given by minus t beta gamma comma t beta of gamma. Now let us consider some problems on the t distribution. Here's the first problem. Find the student's t for the following value in a sample of 8, and the values are -4, -2, -2, 0, 2, 2, 3, 3, taking the mean of the population to be 0, and also test the hypothesis at 1% level of significance, and the critical value at 1% level of significance with sample size of 8 or 7 degrees of freedom, it is given to be equals to 3.5. So here the values given are -4, -2, -2, 0, 2, 2, 3 and a 3. So here x bar would be equals to summation x over n, and here the sample size is equals to 8. So on taking the sum of all these, -2, -2 plus 0 plus 2 plus 2 plus 3 plus 3 over 8, it gives us the value to be equals to 0.25. And s square is given by the formula summation of x minus x bar the whole square divided by n minus 1, which is -4 minus 0.25 whole square plus -2 minus 0.25 the whole square plus so on, and the last value will be 3 minus 0.25 the whole square divided by n minus 1, which is equals to 7, and this is found to be equals to 7.0714, and the test statistic t is given as x minus mu divided by s over root n, which is x bar minus mu 0.25 minus, and here that telling that as to consider the mean of the population to be equals to 0, so mu is equals to 0, so 0 divided by s is square root of 7.0714 divided by square root of 8, and this is found to be equals to 0.2659, and the critical value is given by 3.5. That means we are going to consider the t whether it belongs to minus 3.5 comma 3.5, and here we have t to be equals to 0.2659, and certainly it belongs to this confidence interval of the t-score, so we are going to accept the hypothesis, that is accept the null hypothesis. Okay, so let us go to the next problem. The next problem is for a random sample of 16 values, that is n is given to be equals to 16, with mean 41.5. That is a sample mean. X bar is equals to 41.5, and the sum of the squares of the deviations from the mean equals to 135. That is, sum of the squares of the deviations from the mean, that is sigma x minus x bar whole square, that is given to be equals to 135, and drawn from a normal population. They are asking us to find the 95% confidence limits and the confidence interval for the mean of the population. So here they are asking us to find the confidence interval for the mean of the population, and according to the formula it is given to be equals to x bar plus or minus TC into S divided by root n. So we need to find this one, and they have given that the critical value at 0.05 level of significance for 15 degrees of freedom to be equals to 2.13. So for we need t. For t we need x bar minus mu. In order to find the confidence interval, we need x bar. X bar is known. Tc is also given. We need to find s. We know what is n. So s square is given as summation of x minus x bar the whole square divided by n minus 1. But we know what is summation x minus x bar the whole square, which is 135, divided by n minus 1, it would be 15, and it is found to be equals to 9. So this implies s to be equals to 3. So the confidence limits are x bar plus or minus TCS divided by root n. So that fetches as 41.5 plus or minus TC is 2.13 times S is 3 divided by root n, which is 16, and this gives us the value to be equals to 43.1. So if I am using the plus and if I am using the minus here, it is giving me 39.9. So the confidence interval for the mean of the population is 39.9 comma 43.1. So with 95% confidence, we can say that the for this sample with this sample mean, we are 95% confident that the population mean will belong to the interval 39.9 comma 43.1. The next problem is suppose a random sample of size 10 has the standard deviation of 5.2. What values of x bar will result in the rejection of the hypothesis mu equals 184 at 5% level of significance, given the critical value t.05 of 9 equals to 2.26. So let us write down what are given. Sample size n equals to 10 and the standard deviation of this sample s equals to 5.2. They're asking what values of x bar will result in the rejection of the hypothesis. So the null hypothesis here is mu equals to 184 and the alternate hypothesis is mu not equals to 184. So the hypothesis is rejected. So it is rejected if x bar will not belong to mu minus TC into S divided by root n, mu plus TC into S divided by root n. So let us calculate what is x bar for this intervals. So that means will be rejecting the hypothesis if x bar is less than mu minus TC S divided by root n, or if x bar is greater than mu plus TC into S divided by root n. Okay, less than or equal to, greater than or equals to. So that is x bar should be less than or equals to 184 because mu is equals to 184 minus TC is 2.26, S is found to be equals to 5.2 divided by root 10, or X bar should be greater than or equals to 184 plus 2.26 into 5.2 divided by root 10. So this gives us X bar less than or equals to 180.28 or X bar greater than or equals to 187.72. So if X lies anything below 180.28 or anything above 187.72, we are going to reject the hypothesis, that is the null hypothesis, mu equals to 184. That means mu will not be equals to 184 when X bar lies below this value or above this value. Okay, the next problem is a population random variable X is normally distributed with mean 100. A random sample of size 16 yields a sample mean of 110 and a sample standard deviation of 18.18. They're asking us to test the hypothesis mu is equals to 100 at the significance level of 0.05. Given TC at this level of significance and this degree of freedom as 2.13. Okay, so first let us write down what are given to us. Population random is normally distributed with mean, so that means mu equals to 100. A random sample of size 16, that is n equals to 16, yields a sample mean of 110, that is X bar is equals to 110, and a sample standard deviation S equals to 18.18. They're asking us to test this hypothesis. So let us write down the null hypothesis and the alternate hypothesis. Null hypothesis mu equals to 100 and the alternate hypothesis is mu not equals to 100. And the level of significance is 0.05. So let us calculate T. So T is X bar minus mu over S divided by root n. That gives us 110 minus 100 divided by 18.18 over square root of 16. So this gives us 2.20. So we do want to check whether this T 2.20 belongs to the confidence interval of the T-score, that it lies between minus TC and TC. So minus TC is 2.13 and TC is 2.13. So certainly 2.20 does not belong to this confidence interval. So we are going to reject the hypothesis at this level of significance. The next problem is the bumpers on a new Sabre automobile are supposed to sustain only minor damages in collisions at speeds up to 5 miles per hour. In a test of 5 Sabres, the mean speed for minor damage was 4.8 miles per hour with a sample standard deviation of 0.1 miles per hour. Or the test result statistically significant at the 0.05 level of significance and 0.01 level of significance given the critical values at 4 degrees of freedom and 0.05 level is 4.6 and at 0.01 level is 2.78. So let us write down what are given. So here they are telling that they are testing 5 Sabres. So n is equals to 5. And it gave the sample mean of 4.8. So therefore X bar is 4.8. But in a general population, the speeds can go up to 5 miles per hour. So mu is equals to 5. So let us write the null hypothesis. Null hypothesis is mu is equals to 5 and the alternate hypothesis is mu not equals to 5. So then T is equals to X bar minus mu over S divided, and also S is given to be equals to 0.1, that is a sample standard deviation, 0.1 over root 5, and it is found to be equals to 4.47. So, or rather it is minus 4.47. So we need to check whether this minus 4.47 belongs to minus TC at 0.05 level of significance. It is minus 4.6 comma 4.6, and here you can see that minus 4.47 indeed belongs to this interval. So we are going to accept the hypothesis. And minus at 0.01 level of significance, minus 4.47, we need to check whether this belongs to minus 2.78, 2.78. And here you can see that minus 4.47 does not belong to this interval. So we are going to reject the hypothesis. We are going to reject the hypothesis. Okay, so let's go to the next problem. The next problem states that the mechanist is making engine parts with axle diameter of 0.7 inches. Random samples of 10 parts showed a mean length of 0.742 inches with a standard deviation of 0.04 inches. On the basis of this sample, can it be concluded that the work is inferior at 5% level of significance, and the critical value at this level of significance is given. So let us write down what are given. A sample of 10 parts. So n is equals to 10, and it showed a mean, that is x bar is equals to 0.742 inches, and a standard deviation s is equals to 0.04 inches. But what are they expecting? The axle diameter should be 0.7 inches. That is the mu is equals to 0.7. So let us write down the null hypothesis and the alternate hypothesis. Null hypothesis is mu equals to 0.7. So if mu is equals to 0.7, then the work is good. That is, work is not inferior. And the alternate hypothesis is mu not equals to 0.7. So if this happens, then we consider the work is not good. That is, work is inferior. Okay, so the T would be equals to 0.742 minus 0.7 divided by 0.04 over square root of 10, and this gives us the value to be equals to 3.32. So at 0.05 level of significance, we are checking whether this 3.32 belongs to minus TC, which is minus 2.26 and 2.26. And in fact, this does not belongs to this interval. So we are going to reject the null hypothesis. And what was the null hypothesis? The null hypothesis was mu equals to 7, or the work is not inferior. We are rejecting that the work is not inferior. That is, this implies indeed the work is inferior. The next problem is the following are the IQs of a randomly chosen sample of 10 boys, which are given as 70, 120, 110, 101, 88, 83, 95, 98, 107, 100. So in total there are 6, 7, 8, 9, 10 students. Does the data support the hypothesis that the population mean of IQs is 100 at 5% level of significance? So n is 10, and the IQs are given as x are given. So the x values are 70, 120, 110, 101, 88, 83, 95, 98, 107 and 100. So x bar is summation x over n, which is 70 plus 120 plus 107 plus 100 over n is 10, and it is found to be equals to 97.2. and s square is given as summation of x minus x bar the whole square divided by n minus 1, and this would be 1 over 9 times 70 minus 97.2 the whole square plus so on. The last value is 100 minus 97.2 the whole square, and it is found to be equals to 203.73, and t is equals to x bar, which is 97.2 minus, and here they are asking you whether the data supports the population mean to be equals to 100, that is mu is given to be equals to 100 over s square is 203, so s will be square root of 203.73 over root 10, and it is found to be equals to minus 0.62. Okay, so now let us write the null hypothesis. Null hypothesis is the mean IQs is equals to 100, and the alternate hypothesis is mu not equals to 100. So here we need to check whether this minus 0.62 belongs to minus TC comma TC, and TC at 5% level of significance, T 0.05 for 9 degrees of freedom, it is 2.26. We need to check whether minus 0.62 belongs to minus 2.62 comma 2.62, and indeed it belongs to this one. That means we are going to accept the null hypothesis. So accept the null hypothesis, and the null hypothesis was the population mean of IQs is 100. The population mean of the IQs is 100. Okay, so let us go to the next problem. In the next problem, it states a certain stimulus administered to each of 12 patients. Each of 12 patients resulted in the following change in blood pressures. So these are the changes in the blood pressures of the 12 patients. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can it be concluded that on the whole the stimulus will change the blood pressure, and they are asking us to use this critical value. So n there are 12, and the change in the blood pressures are 5, 2, 8, minus 1, 3, 0, 6, minus 2, 1, 5, 0, and a 4. So can it be concluded that on the whole the stimulus will change the blood pressure? So this is the change. So there is a change of 5 units, and here there is a change of 2 units, and here you see that there is no change at all, and here also there is no change at all. So our null hypothesis will be there is no change in the stimulus administered, that is the mean equals to 0. And the alternate hypothesis would be there is a change in the stimulus administered, that is mu not equals to 0. It can be anything. So from the available data we can find the x bar, which is 5 plus 2 plus 8 so on plus 0 plus 4 divided by 12, and it is found to be equals to 2.58, and s square would be equals to 5 minus 2.58 the whole square plus 2 minus 2.58 the whole square plus on 0 minus 2.58 the whole square plus 4 minus 2.58 the whole square, everything divided by n minus 1, which is 11 here, and s square is found to be equals to 9.5379. So the t value is x bar 2.58 minus mu, which is 0, divided by square root of 9.5379 divided by root n, which is root 12, and it is found to be equals to 2.89, and we need to check whether this belongs to minus TC, that is minus 2.20 comma 2.20, and you see that 2.89 does not belong to this interval. So we are going to reject the hypothesis, reject the null hypothesis, reject the null hypothesis. So the null hypothesis stated that the stimulus administered would not change the blood pressure, and we are rejecting that hypothesis. That means we can say that the stimulus is likely to change the blood pressure. The next problem is as follows. 11 schoolboys were given a test in mathematics carrying a maximum of 25 marks. They were given a month's extra coaching and a second test of equal difficulty was held thereafter. The following table gives the marks in the two tests. So this is for test 1 and this are the for the test 2. So the test 2 is given after 1 month of coaching. Do the marks give evidence that the students have benefited by extra coaching? And they're asking us to use the 0.0 level of significance, and the critical value is given. So here we can state the null hypothesis as the students are not benefited. That means there is no change at all. So mu is equals to 0. So the students not benefited from the extra coaching, and your HA will be mu not equals to 0. That means the students have benefited from the extra coaching. So here what we will be doing is we will be taking the difference in the two test scores. So the difference will be T2 minus of T1. So it would be 24 minus 23, which is 1, then minus 1, 3, minus 3, 2, 2, 2, 3, 0, 20 minus 16, 4, 17 minus 19, which is minus 2. So these are the X scores. And here the total number of students is how many? 11. We will find the X bar again using the summation X over N. And it is 1 minus 1 plus 3 minus so on plus 4 minus 2 divided by 11, and it is found to be equals to 1. And your S square will be summation X minus X bar the whole square divided by N minus 1, and it is found to be equals to 1 minus 1 the whole square plus minus 1 minus 1 the whole square plus so on plus 4 minus 1 the whole square plus minus 2 minus 1 the whole square divided by n minus 1, which is 10. And it is found to be equals to 5. And T is calculated as X bar, which is 1 minus mu is equals to 0 divided by S square, which is square root of S, which is root 5 divided by root of N, which is 11, and it is found to be equals to 1.48. And we need to check whether this belongs to minus TC minus 2.23 comma 2.23, and we observe that 1.48 belongs to this interval. We are going to accept the null hypothesis. That means what did we state? The null hypothesis stated that there is no difference in the marks. So that means the students are not benefited. So that is the students have not benefited by extra coaching.